Bismillahirrahmanirrahim. Assalamu alaikum, dear students. Hope you are good and enjoying your good wealth. So today we are going to learn about demonstrative geometry. So what is demonstrative geometry? So in demonstrative geometry, theorems on geometry are proved through logical reasoning. Now what is logical reasoning? So logical means through formal arguments, and reasoning means the action of thinking. So the reasoning means that the way of thinking through formal arguments. So what are the basics of reasonings? Number first, undefined terms. From its name it is clear that is undefined. So these are the concepts that are accepted without defining them. It means that there is no need to prove it. Without defining them, we have to accept it, these terms. For example, in mathematics, point. So just a single point, there is no definition of a single point. So point, plane and space are the undefined terms. Then the fundamental agreement are basic assumptions. So with the help of undefined terms, certain statements are accepted true without proofs. It means that for the basic assumptions, we are accept it without proof, with the help of undefined terms. Now what are the basic assumptions? Number first are called axioms. So axioms are the assumption related to the numbers are called axioms. So for example, every number is equal to itself. It is an axiom. Now postulates, it is also basic assumptions. So the assumption related to the geometrical figures are called postulates. So whenever we have some geometrical figures and we are dealing with the assumptions, so such type of assumptions are called postulates. Like for example, one and only one line passes through two distinct points, or rather than we can say in geometry we are dealing with triangles. Like we are going to prove it to congruency or similarity, to we have to check it as side or side angle side. These all are called postulates. Now come to the main topic, that is called theorem or propositions. So theorem are also called propositions. So most of the students are don't know about theorem, that what is a theorem or proposition. So let's learn about theorems. So theorems are the statements that are proved with the help of axioms, postulate and undefined terms. Now we have learned about axioms, postulates and undefined terms. So theorems are just statements which can be proved with the help of these terms. For example, sum of angle of a triangle is 180 degree. This is a theorem which can be proved with the above terms, axioms, postulates or undefined terms. Now there are some types of theorems. Let's we learn about the types of the theorem. Number first is called the geometrical theorem. So it is very clear from its name that a theorem involving geometry is called a geometrical theorem, or we can say the theorem that are proved with the help of principles of geometry are called geometrical theorems. So for example, opposite angle of a parallelogram are congruent. So here we can see that the parallelogram is included here. So parallelogram is what? Parallelogram is a type of geometry. So when we are going to prove it, so such type of here we will use it, the principle of geometry. So that's why this theorem is called the geometrical theorem. Now corollary. What is corollary? So the results obtained from the theorem is called corollaries, or which can be deducted directly from the theorems are called corollaries. So theorem, opposite angle of a parallelogram are congruent. So what will be corollary? So its corollary will be like this, that opposite angles of a rhombus are congruent. So this is about theorem and corollaries. So now what is the converse of a theorem? So a theorem has two parts. One part is given and the another one part is to prove. So if the given part of a theorem is to prove part of the other theorem, and the given part of the other theorem is to prove part of the first theorem, then such type of theorems are called the converse of the theorem. So for example, we are here a theorem that if two arcs of a circle are congruent, then the corresponding chords are equal. Here in this theorem, the given part is two arcs of a circle are congruent. It is given, and we have to prove it that the corresponding chords are equal. So now the converse of this theorem will be like this, that this second part of the theorem, that is to prove, will be come here in terms of given part. So read it like this. So converse of this theorem, if two chords of a circle, now here this one chord, here chord are to prove, but here it is given. If two chords of a circle are congruent, then the corresponding arc are congruent. So this is about the converse of a theorem. Now parts of theorem, that are the most essential parts of a theorem. If you understand these parts, so you will easily prove it. Number first is called statement. Statement is the description of the geometrical theorem in words, is called statements. So in statement have two parts. One part is given, which in mostly theorem it start from if, and the second part is to prove, which is mostly start with this, then or is. So the another part of the theorem is figure. So the visual scene of the statement in the form of geometrical drawing is called figure. Then construction, sometime figure need additional drawing necessary for the proof. So this additional drawing is called constructions. Now let we apply all these things on a theorem. That this theorem is from grade 10, exercise theorem 8.1. So in an obtuse angle triangle, let we try to understand this statement. So first of all, you people must know about what is an obtuse angle triangle. So obtuse angle triangle is that triangle in which one angle is greater than 90 degree and less than 180 degree. So if you see here, this is an obtuse angle triangle in which this angle is obtuse angle. So the square on the side opposite to the obtuse angle, so the side opposite to this obtuse angle is equal to the sum of the square on the sides containing the obtuse angle together with the twice the rectangle contained by one of the sides and the projection on it of the other. So from here we can see that that the square on the side opposite to obtuse angle. So the side opposite to obtuse angle is this side BC. So they are so it means that BC square is equal to what? The sum of the square on the sides containing obtuse angle. So the side which contain obtuse angle, so this side and this side, so the square of this and their sum. So AC square plus AB square together with the twice mean two times the rectangle contained by one of the sides. So if we are going to complete this rectangle, so this one is one of the side, so it means that 2 times BD. So BD we will write BD like this, 2 times BA and AD. So this is the statement of this theorem. So here given the given part of this theorem is it is an obtuse angle triangle and the square of this side obtuse. So we have to prove is, we after is we will prove it. So is equal to the square of these two sides, the sum of the square of these two sides, and 2 times the this side, which is one side of the rectangle. So given ABC is a triangle having obtuse angle BAC. So here is an obtuse angle. So drop CD, which is perpendicular to this AB on BA produce, so that AD is the projection of AC on BA produce. For here is another term, that is projection. So we people are must be clear about the projection. So the projection of a line segment CD on a line AB is the projection EF. So here in this figure we can see very simply that the projection of CD is simply EF, like we can say the shadow of this one. So here this AD is the projection of AC. So that AD is the projection of AC on BA produce. So let's take them their names. BC is supposed to be AB is supposed to be B, and AC is supposed to be B, and CD is supposed to be H, and AD is supposed to be D. So we are going to prove this statement, and that is already explained. So now proof. If you see here, for this short right angle triangle CDA, this one angle is 90. So this angle D is 90. So by Pythagoras theorem, the square of the hypotenuse is equal to the sum of the square on the other two sides. So AC square will be equal to AD square plus CD square, like this. So it can also be written that B square is equal to X square plus H square. So let name them equation 1. Now if you see in the big triangle, right angle triangle BDC, so this angle is 90 degree. Again use Pythagoras theorem. So for this hypotenuse will be BC. So BC square is equal to BD square plus CD square. So here this BD have two parts, C and X, so it can be written C plus X whole square. So it can be written A square C plus X whole square plus H square. Or using expand it, so it become C square plus 2CX plus X square plus X square. So this is equation 2. If you see in equation 1, X square plus X square is B square. So replace X square plus A square by B square. So if we replace it by B square, so it will become A square is equal to C square plus 2CX plus B square, or it can be written A square is equal to B square plus C square plus 2CX, or it can be written in terms of their side, BC whole square is equal to AC square plus AB square plus 2 times AB into AD. So thank you so much for listening us.